Good morning, grade 12s. Our first topic for grade term 2 is analytic geometry. In the November examination, analytic geometry has two questions. The first question is a grade 11 analytic geometry pure, and the second question is a grade 12 geometry question which involves a circle. However, you need some basic skills in that question. That is the second question. Let us go over last year's work. A quick reference in terms of all our analytic geometry formulas. Let's start with the distance formula. In terms of the distance formula, this formula will appear in the data sheet, this particular one, but they'll have a D here. Just note it's a square root. If they ask you to find the distance between two given points, please read the instruction. If they said leave it in third form, then you're not allowed to use the calculator. If there's no instructions, then just basically use your calculator to get the value. Generally, candidates make a lot of mistakes here in the substitution, especially when there is a negative coordinate. Note it's x2 subtract x1 all squared plus y2 subtract y1 all squared. When you're working with a question, it's an advantage if this is a given point A, which is -3 and -4, and this is the point B, which is 2 and 3. It's nice to write down for your references which 2 points you want x2, y2, or any way. Preferably let your 2 be the positive ones. Having said that, let us continue with the next formula. The next formula is the midpoint formula. Very useful, very important. And note once again the formula, make reference to the formula sheet that is provided for you. So the midpoint are the sum of the two coordinates divided by 2 for x's, and the sum of the two coordinates divided by 2 for the y's. Also be careful with negatives. We tend to make a lot of mistakes when it comes to the substitution into the formulas. And the most important thing in grade 11 that we studied was the gradients. It lends itself to a number of different types of questions. The gradient formula is y2 subtract y1 over x2 subtract x1. It's important that you create a reference for yourself. Just don't write m equals to and state the formula. If they're telling you to find the gradient of a line PQ, then state gradient of PQ for you and for the person who's marking your script. Once again, in your haste, you would make a mistake where you would write this as a formula and there's no mark. Do not rush into the paper. Don't interchange your formula. If you decided to have y2 subtract y1, don't now say x1 subtract x2. That formula is wrong. So be careful. Once again, mark off the points, which is your x2, y2, and then substitute correctly. The byproduct of, or the continuation of gradients is the following. 1. Collinear. 3 points are deemed to be collinear if they lie on the same straight line. So these 3 points A, B, C are collinear. Then to prove them they are collinear, then one must check the gradient of AM and then calculate the gradient of the gradient A of AB and the gradient of BC. You calculate them. If they are equal, then you prove them. Prove that their lines are on the same straight line, hence collinear. If given that they are collinear and you have a missing, let's say, a coordinate x, then they may ask you to calculate that or within a context of a question. So make sure that you understand the notion of collinear. And the grade 11 work that we've done was analytic geometry. This is the formula. Analytic geometry determines the angle between the line and the x-axis. A little bit confusing for learners. This is the angle of inclination. The angle of inclination refers to the angle that the line makes to the x-axis. There are two types of angles here. One is an acute angle and one is an obtuse angle. There's a formula, m is equal to tan of theta. This is an obtuse case, and it is important that you check the examples when you have an obtuse case, because it'll be this. You have to work out your gradient as an acute case and then subtract it from 180 degrees and you'll get your obtuse angle. Go over your last year's notes that we given you in 2018. Note that when your gradient is positive, then you're going to get an acute angle. When your gradient is negative, then you're going to get an obtuse angle. So it requires a little bit of thinking involved there. The next thing involving gradients are parallel lines and perpendicular lines. So if AB is perpendicular to DC, then the product of the gradient is always equal to -1. Important fact to remember. So when you see the word perpendicular, associated with the gradient multiplied equal to -1. When two lines are parallel, then the gradient of one line is equal to the gradient of the other line. Very, very, very important. Has lots of implication in your questions that you're going to answer. Then the last thing that we need to go over is the equations of straight line. Here two options that you have. You could use this fancy formula where x1 and x2 or x1 is a given point, not x2, x1 and y1. You substitute, but however you must have a gradient. So two things are required: a given point, the coordinates of point, and the gradient must be given. Use this formula. Once again, watch out the substitution, or use y equals mx plus c, where c is the y-intercept, which in many cases you'll have to calculate by substituting. You'll substitute your gradient, therefore you'll have an incomplete equation. Then you substitute your given points for your x and y, and then calculate your c. A very, very important thing that you need to go over is your grade 11 quadrilaterals and their properties and how to prove them. And these are general questions that they will ask you in the first question and the grade 11 analytic geometry. Let's go over the summaries. Firstly, we've learned what's a trapezium. The trapezium is a quadrilateral with one pair of opposite sides parallel. Because they're parallel, and the gradient of this line is equal to the gradient of that line. They will not give you a horizontal or vertical kind of quadrilateral. So this is the property. Parallelogram or palm. Palm is a quadrilateral with both pairs of opposite sides parallel. That's the definition. But one of the consequences of having a parallelogram, you know that the opposite sides are equal, the opposite sides are parallel, the opposite angles are equals, and most important, the diagonals bisect each other. So to prove a quadrilateral to be a parallelogram, we could use any one of these three options. I would prefer this one here, but when we'll see an example in which you're going to attempt, then you would check which is a better option for you. But this is an easier one to work with. The next important thing when it comes to parallelogram, they may ask you to find the coordinate of the fourth point. They'll give you the coordinate of that point, they'll give you the coordinate of that point, they'll give you the coordinate of that. So they give you coordinates of 3 points. You'll be then asked to find the coordinate of the fourth point. Interesting question, comes out very often. Then you have rectangles. Rectangles is a parallelogram first, so all the properties of the parallelograms will apply, and the diagonals are equal with an additional fact that the diagonals are equal and all interior angles are right angle. In other words, they are right 90 degrees. So the diagonals are equal and they're equal to one another. They bisect one another. In a parallelogram, the diagonals just bisect each other. There's a difference between one another and each other. One another means that all four diagonals are bisected, and two diagonals are bisected with equal parts. In a parallelogram, they dissect each other. It means this shorter diagonal has a midpoint of E, and the longer diagonal has a midpoint of E as well. But this line is equal to that, and that line is equal to that. Keep that in mind. It's quite interesting to remember. Rhombus, very, very, very important. You saw in the 2 and 3 dimensional problems, they asked you and they gave you a rhombus, and therefore you needed to know all the properties of a rhombus. Okay, so let's go through them. It's a parallelogram first, so all the properties of parallelograms are applied with a condition that all sides are equal. The diagonals bisect at 90 degrees, very useful because you could work the gradients multiplied equals to -1. The diagonals bisect the angles, not so important in analytic geometry, but could help you in angles of inclination. And all four sides are equal in that, very, very important. Then you have a square. A square is a specialized rhombus in that it's a parallelogram, it's a rectangle, and therefore it obeys all the properties of a palm. 90 degrees, all sides are equal, and the diagonals obviously would be equal, and they bisect each other. And because it's a 90 degrees, then diagonals of a rhombus and a square bisect the angle, therefore that will be 45, 45. These facts are also very important for the section that we're going to do towards the latter part of term 2, that is calculus. And it's a problem solving question, so please make sure that you go over all your properties. When these notes are posted up, spend some time on page 3. It's quite interesting, and make some mental notes for yourself. Kite is it's a quadrilateral. Basically, it's two isosceles triangles sharing a common side. So triangle ABD is a isosceles triangle. That means adjacent sides are equal. And triangle BDC, BC is equal to DC. Therefore, it's an isosceles triangle. And let's look at it. The kite is a quadrilateral with two adjacent sides equal. So that side is equal to that, and this side is equal to that. The nice interesting properties. Firstly, the adjacent sides are equal. The long diagonal bisect the short diagonals. The long diagonals bisect the angles. Okay, let's go through this one. So the long diagonals only bisect the angle. Very interesting. The long diagonals bisect the short diagonals, and the diagonals intersect at 90 degrees. So there's 3 things. The long diagonals bisect the angles. The long diagonals bisect the sides, the shorter diagonals at 90 degrees. And look at one worked out example of involving parallelogram. It says use analytic geometry to show, read the instructions carefully, to show that PQRS is a parallelogram. Note they gave you the coordinates of all points, and you know that these two sides are parallel and these two sides are parallel to each other. The diagonals bisect each other. Try not to mark too much things on your diagram. It will complicate you. It will confuse you basically. So one of the ways we want to show that this is a parallelogram. Remember, we don't know it's a parallelogram, so we don't know that the sides are parallel. We want to show that, but that's a consequence after we showed it. So if it's a next question and you haven't shown that it's a parallelogram, you may have forgotten the method, but you could use that important fact in, say, question 3.2. Okay, so what we do is we work out the midpoint M of QS, and once again substitution. Be careful how you substitute. Watch the negatives, use brackets for negative, and write down the formulas. Substitute, and you will get the midpoint to be 7/2 for x and half for y. Then you work out the midpoint of PR, same method, Once again, use formula brackets for negative. They didn't do it here, but it doesn't matter, and you will get the same answer. Use a calculator. Please don't use mental maths, because you'll be under tremendous stress in the examination and you will tend to make mistakes. You'll get 7 over 2 and you'll get half. Therefore, the midpoints are equal. The midpoints of QS is equal to the midpoint of PR, which is equal to the coordinates of M, and therefore the PQRS is a palm because the diagonals bisect each other. Very interesting exam. Spend some time to do this. There are other methods, but this is good enough to know one method. Now let us look at a 2019. This is November 2019. Question number 3. So question 1 and 2 is data handling. Question 3 generally is the analytic geometry question. So let's go this. In the diagram, so they're going to explain this to you. Okay. In the diagram, P, which is an unknown coordinate, R, which is 3 and 5, S, which is minus 3 and minus 7, and T, which is minus 5, and K are vertices of a trapezium. And they give you additional fact that PT is parallel to RS. So in other words, the gradient of this line is the gradient of the line. They are equal. Important fact, because you couldn't have found the gradient here. And remember, you got an unknown coordinate in T, that is the Y. They explain now further that PR cuts the y-axis at D, so therefore it's a y-coordinate, and one knows the y-coordinate is going to be 0 and something. So clearly they may ask you a question to find that coordinate, and we're going to look at how we can do that. And C is the coordinate. C is the bottom one here. C is the coordinate 0, 5. It is the x-intercept. Note, that's a y-intercept. Note that it's a x coordinate is 0. Okay. E and F are also the x coordinate. Maybe they'll ask you, we're not sure. They gave you an angle. That angle PEF is equal to theta. So clearly there's an angle of elevation or inclination, angle of inclination, and you are expected to find that. The rest is just a further explanation. Let's look at the first question. So the first question says, write down the equation of PR. Now, one of the questions about PR, if you examine and you see that the y coordinates of PR are the same, 5 and 5, and that implies that PR is a horizontal line. And if it's a horizontal line, then your y coordinates are equal. If 2 points form a vertical line, then the x coordinates are going to be equal. Very, very important fact to notice. Notice it's 1 mark, so it's straightforward. It's something that you should have learned from grade 10. Then they ask you a whole series of questions. Calculate the gradient, easy, 2 marks, must get. Calculate the angle, 3 marks, must get. So if we calculate that 6 out of 300, that's paper 1 and paper 2 put together, is 2%. So 2% of something simple. And to calculate the coordinate of D, which is 3 marks, remember we know that's 0, and we're going to look at the solution just now. How do you go about getting it? Okay, so far we've got 9 marks, which is 3%. Then they gave you some further information. They tell you if given that T is the square root of 2 square root of 5, so this is the distance or the length, and they're expecting you to calculate an unknown value. Please note that KT is in the third quadrant, and because it's in the third quadrant, both x and y are negative. Nice for you to note that, because you may just get a quadratic equation and you need to check which one is valid and which one is not valid. Then they gave you the TDS, TD and S with N is in the fourth quadrant. Calculate the coordinate of N. Note, it is not drawn for you. So clearly we need to draw it and make sure that we understand that question. Now let's look at the solution question by question. What I've done for you is to give you the memo, because I want you to see the mark schemes. Okay, so generally they will give you the diagram again. Remember, in June exam, trial exams, and the November exams, you will be given a prepared answer booklet. So make sure that you know how to use it. So 3.1, the equation of PR is 5. 1 mark for the answer. Accuracy, nothing else. If you put y equals 4, nothing, no marks. Then they ask you to find the gradient of the line PRP, gradient of RP. There's a reason for that, because that gradient has, this line here has 2 numerical values, so I can find that gradient, and therefore it's a gradient of PT. So once again, substitution in the formula, y2 subtract y1 over x2 subtract x1. Decide which is your y2 in your question. Always make the positive the 2 coordinates. That means x2 y2 and x1 y1. Okay, substitute and you'll get 2. Notice full marks for answer only, but try not to show the working. 1 mark for substitution, 1 mark for the answer. Now that we want to find the angle of inclination, that is theta of PT. So we know for a fact that these 2 lines are parallel. PT is parallel to RS, therefore the gradient of RS is equal to the gradient of PT. Notice how they write that down. 1 important mark for that, for stating it. So make sure that you write that step. And then applying the formula, tan of theta is equal to 2, and theta is equal to 63.46. Now that is calculator work. So you will actually say tan inverse of 2, and you will get your answer. Right, so far so good. If you said perpendicular, you got no marks. These are comments that the person who marked is an examiner, is a marker, wrote some notes on his memo. Now they asked us to find the equation of RS. The equation of RS, there are 3 methods here. I'll prefer the method that we have, the substitution method. So y2, y subtract y1 is equal to m into x minus x1. Apply this formula and you notice that you get, always write your answer in y form. Please practice this part. This is your responsibility. And you know D is the y-intercept. So therefore it's going to be 0 and minus 1. Okay? Don't worry about the CAA mark. If you made a mistake here, then that will continue here. But provided that it's a positive gradient. Okay? If you have a negative gradient, and then there's another issue there. Okay, let's remember it's positive. Okay, there's another method where you found using the gradient formula, and where you said D is 0 and y, and you can get the same desired answer. Okay, let's look at the next question. 3.3. In 3.3, if I remember clearly, they want you to find, they're given the distance here to be 2 square root of 5, and they want you to find k. So once again, remember the distance formula is D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. What you need to do now is to decide once again which is your x2, y2, and substitute it into the formula. They decided, and quite correctly, made this the x2, y2, made this the x1, y1. Always the one above, make that true. Watch your substitution, watch how you set up your question. So st is equal to the square root of 2 square root of 5 is equal to, you can write the formula if you wanted to, but here they went straight into it. They substituted and then they squared both sides. Use your calculator to do this, and you got 20. When you square the side, simplify carefully because you make a lot of mistakes here too. Use your calculator. Don't trust you with your mental calculation. Use your calculator to get 4, and then you got k plus 7 all squared. Spend some time here because you tend to make a mistake. Then isolating the square root. When we got rid of the square root, now keeping your unknown to the left hand side. Here they found square roots on both sides, and k plus 7 is equal to plus minus 4. Therefore k is equal to minus 11, or k is equal to minus 3. Or you can multiply it out and use quadratic, and you could use your 991 to find both the answers. Remember, there's 1 mark for factors. So if you go from here to here and you leave that, then you lose a mark. So please, when you're using your calculator, when you get minus 11 and minus 3, go back and don't forget that step. This method didn't require any mark for factors. So but if you, once you have a standard quadratic, the next mark is going to be, so 1 mark for standard quadratic, 1 mark for factors in all questions. Alright, then the last question in this section is we wanted to find the coordinates. Now what I recommend you do is to draw a diagram on this question and try to work out how the diagram looks and then apply it in terms of that. So what they did was, so they said n is somewhere around here. Let's just go back to the question again. They said find if T, D, and S is a palm. So in that order, T, D, and S. So somewhere around here. And that is a palm. Okay, so we need to find that. So it's in the 4th quadrant. So one is X is going to be positive and Y is going to be negative. So let's just go through this again. So N is somewhere around here. Let's make it here. That is your quadrilateral. That's your parallelogram. They gave you that, and they want you to find the coordinates of that. There are 2 methods. One of the method is using your midpoint theorem or transformation. So let's look at transformation. So if you look at the coordinate T, which is a given coordinate, which we calculated now to be minus 5 and minus 3, minus 5 and minus 3, and that transforms to S, which is minus 3 and minus 7. Now what you want to do is you want to take the coordinate of D and apply a formula. Now if you look at, you got minus 5 and you got minus 7. The only way you can get minus 5 to look like minus 7 is to look minus 3 actually, is to add 3. So minus 5 plus 2, not 3, 2 will give you minus 3. So I'm taking X and adding 2 to it. And if you take minus 3 going to minus 7, the only way you can get that is to take minus 3 minus 4 will give you minus 7. And there's the formula here. Okay, so in other words, D going to, now remember, D is 0, 1. To move from there to there, you got the formula that you did, where we said that it will be X plus 2 and Y minus 4. So we're going to apply that same transformation. Remember, this is transformed from there to there. And when you apply that, then you're going to get D going to N will be 0 plus 2 or minus 1 minus 4. The formula that you discovered and you'll get your formula, your answer for n. Much easier, better to go through. Or you could use the midpoint, as I said to you, that the midpoint of Tn is equal to the midpoint of Sd, and you call your point n to be x and y. So x plus minus 5 divided by 2 is equal to minus 3 plus 0 divided by 2. And you solve for x by cross multiplying and doing the normal basic maths, and you'll get to 2. And then y plus minus 3 divided by 2 is equal to minus 7 plus minus 1 divided by 2. This is a straight line still, and therefore you'll get 5. Okay, answers only 4 marks. I don't know how you can get your answer in one go, but please go over these 2 examples. Your homework due on Thursday is your November 2018 paper, which appears in your notes that I'm going to upload. Thank you very much. Have a good day and be safe, and do some work, boys and girls. As I said to you previously, without fail, the November examination is a reality. It may just be slightly delayed, but we have to write those exams. Thank you. Do your homework today, and we will correct it on either Wednesday or Thursday. Thank you very much.